Okay, example number 4, 4x squared minus 25 equals 0. Let's factor that. Now in this case, again, just like in example 3, we actually have the difference between two perfect square. So we can rewrite 4x squared into the term of 2x raised to the second power and 25 into 5 raised to the second power. Okay, and of course these two terms are the perfect square because if we take the square root of 4x squared using the zero products property, we have the product of square root of 4 times square root of x squared. Well, that's going to turn into 2 times x. So that's how we know that 4x squared is a perfect square. And same thing for 25. Take a square root of 25. That's actually going to give us positive 5. Okay, and of course positive 5 multiplying itself twice is going to give us back 25. And the same thing for 2x. 2x multiplying itself twice is going to give us back 4x squared. So this is the difference between two perfect squares. Well, in this special case of the difference between two perfect squares, the way you factor it is that you keep these two terms inside of parentheses. 2x and 5 over here in this empty parentheses, and then you do the same thing for the next one, 2x and 5. Now in between, in each of these parentheses, you're going to have a minus and you're going to have a plus. So maybe one way to understand this or to keep in mind is I just think of these two terms as a, quote-unquote conjugate of each other. Okay, so hopefully that's going to help you remember how to factor the special case of the quadratic equation called the difference between two perfect squares. But guess what? We got two binomial factors equals 0 by the zero products property. Set each of these binomial factor equals 0. And then you solve for x. So on the left, we're going to have 2x equal 5. Get x by itself by dividing both sides by 2. X equal 5 over 2. In the case on the right, we're going to have 2x equal negative 5. Divide both sides by 2. You get x equal negative 5 over 2. Okay, and of course, make sure you plug in each of these x value and you check for the solutions. Okay, to check to see if either one of these two x values or both of these x values or none of these x values are the solution of the original equations. Okay,